So I decided I would try to do a video here to show you what this program actually looks like when it executes. And I've tried to decide how I can best give you that information. So clearly in the web page that you see this video within, it explains the process that I went through to write this program. And this is just a quick summary of what it looks like in action. So to show you the program itself, I've enlarged the text here. This isn't actually within the development environment, so I can explain the different commands just so you understand what you will eventually see. So when you open Python itself, that doesn't have activated, that hasn't activated the turtle component. So the first command, import turtle, just brings in all that functionality. And then you'll see I set up a couple of variables. S is for screen. And when you do that, what's going to happen is a second screen is a second window, I guess to be more accurately described as, opens. And that's the window within which the turtle will appear and execute the program. T then sets up T as the turtle itself. And then after that, you'll see just T rather than writing out turtle. So and then basically acting on turtle, and the first thing I do, T.pen size 5. That's just to make the width of what turtle draws wider, so it's easier to see. Then you see a loop. And the loop goes from basically 1 to 360. And of course, 360 number of degrees completely around. And so this loop is going to execute 360 times. The first T.write I turns the turtle to the right I degrees. And then T.pen up, the pen is down by default. And if you bring the pen up, then you can move the turtle without anything appearing, any drawing appearing. T.forward 200 is going to move the turtle ahead 200 steps from its start point. T.pen down puts the pen down again, and now T.forward 2 moves the turtle forward 2 turtle steps, and because pen is down, it's going to draw basically a little dot that's 2 turtle steps long, and then T.pen up puts the pen back up, and T.home returns turtle to its starting point. All right, so that's the program. Import the turtle, set up the screen, set up this 360 times loop, and then loop through those commands of starting from the point, moving out, putting the pen down, drawing a dot, coming back, rotating, and then doing the whole thing again. That's what that's going to look like. All right, so what I'm going to do now is go through the process of activating Python and showing you what that command, what that program will look like. So essentially, I have downloaded Python and it's installed, and the instructions for doing that are in the page. So come down here and I should find Python. There it is. And what I'm looking for is idle here. And what idle does is launch first the terminal, and then within terminal, it's going to launch Python. And so now you can kind of recognize this as essentially the terminal, but you can see that within it, it is activated Python. So, okay. So now we have Python running. And what I'm going to do is bring in that program that I described for you. So I'm going to open it. And let's see, it's on my desktop. And it's right here. You can see the program now. It's going to bring it in. And now what I'm going to do is run it, and that should execute that entire process that I described for you before, importing the turtle, opening that second window, and then going through that iterative process that results in the turtle. So I'm going to run the module. There you see the window opening. And it happens very, very quick, but you can see the beginning. I'm not going to make you sit through the entire circle, but you can see it drawing the circle. Now, what I find fascinating about this goes back to what Seymour Papert described when he talked about the benefits of logo. And he talked about different ways of understanding geometry, which is, I guess you would say, what we are playing with here, and that there are different ways of understanding geometry. This is different. He called this a computational way of understanding. And this example, the circle, has always been my favorite example of what that means. Because as I tell people, and I'll tell you, I think we all memorized a definition of circle at some point, and we learned, various attributes of this geometric shape. But we learned a definition that went something like a plane closed figure, which is, if you can imagine the screen here as a plane, and of course a circle eventually will be closed, consisting of all points equidistant from a point. Now, we memorize that, but to truly understand what that means is a different thing. And there's a difference between knowing the definition, I think, and understanding the idea of a plane, the idea of a closed figure, the idea of all points equidistant from a point. And essentially what this program is doing is acting on that definition. It's in a plane, obviously. It's creating eventually a closed figure, and it is going out the same distance from a point to add another point, and that basically results eventually here in a circle. So I hope seeing this in action brings home kind of the point I was trying to make about this way of understanding through computation, and maybe now you understand why I keep coming back to the idea of this circle to demonstrate what Papert meant by learning through computation.